Does this microphone have different channels?
You have a problem?
Yeah,
Can I help?
I don't think so. Basically, there is no channel in the mic. It's there, but we can't hear. Okay, we go live and see.
If there's no sound though?
There is sound, but doesn't come from the mic.
So where's it coming from? Scratching? Well, welcome to National Science Week 2020 at QVMAG. My name's David Maynard and I'm the Senior Curator of Natural Sciences. I'm going to be speaking to you about an exhibition we've just opened, Estuary Below the Surface. To start off with though, we're going to show you a short video of the layout of that exhibition. We'll be back shortly. Martin's got sound. Welcome to National Science Week 2020 at QVMAG. My name's David Maynard and I'm here to talk to you about the exhibition Estuary Below the Surface. This will be one of two exhibition-related topics that will be presented by QVMAG this week during National Science Week. Estuary is the story of Canamalooka River Tamar, the waterway that we all are quite familiar with and is really the focus of Launceston and the people that live along the Tamar Valley. One of the major misconceptions with the Tamar is that it's a river, and that is wrong. It is an estuary. So what is the definition of an estuary? It means a body of water that is open to the ocean at one end and is fed by fresh water at the upper extent, and that you can measure the salinity, the variation in the salinity along the length. So whenever we talk about the Tamar, we really need to call it the Tamar Estuary. So what's in a name? The thing here is that there's great differences between how a river functions and an estuary functions. And that difference implies how we look after the estuary, how we manage the estuary. Here we have a map of the catchment. The catchment is the part of Tasmania's landmass that drains down into Launceston. How we use the land in the catchment can really affect the water quality that enters the Tamar at Launceston. Things like agricultural runoff, nutrients from other sources, and even sediments from erosion end up in Launceston. And that water from the catchment enters Launceston through the South Esk and the North Esk. And one of the most visible features of that water are the sediment banks that build up around Launceston. They're quite contentious, yet they are mostly natural features. Estuaries always infill, and sediments are part of estuaries. Next, I'd like to show you some of the subtidal habitats so that you understand how much sediment is in the Tamar. Just to highlight how prevalent soft sediments are in estuaries and here in the Tamar, this map here shows in orange-brown the extent of soft sediments. Nearly 60% of our estuary is made up of soft sediments. That is a normal thing for estuaries. Each of the different habitat types supports different plants and animals. And so here at the head of the estuary, you can see a range of different colours representing different habitats like sand, rocky reef, cobbles and such. And each of those supports a different suite of animals. Now I'd like to show you some of those animals. So there you go, there's a quick overview of what the exhibition looks like. However, rather than go through each of the images in the exhibition, I thought I'd provide you with a little bit more background and context to how the images were chosen. And to start with, I will show you a couple of the images, the idea being that the exhibition has images of individual animals that were cherry-picked out of a background habitat. And so here in the top left corner, we've got a colourful nudibranch, or a sea slug. If our garden slugs look like this, we might want to keep them, but the bright colours there highlight its toxicity. It feeds on those sponges in the background and it accumulates those toxins, the colours being a warning to predators. Then below it, we've got a magpie perch. These guys live in algal beds, which are over hard rocky reef, and they feed by sifting sand that accumulates in gutters through their gills. They retain the food and they eject the excess sediments. And you can see that on the black stripe there on his back. He's got some of the sediments stuck to his slime coating. And then the next one there is the pink-tipped or purple-tipped anemone. It's living at in the transition zone between where photosynthesis is possible and and then where there's not enough light for plants to grow, so the invertebrates take over. And in this case, you can see there's some soft sediments in amongst the disc in between the tentacles. He would have his tentacles out waving around trying to catch food. When food touches those tentacles, there's a small toxin delivered through a cell called a nematocyst. The prey is paralysed and it's passed to the central mouth. So these are the kind of images and stories that are available through the exhibition. But rather than go through each of those, I thought we'd have a look behind the scenes, particularly at the various habitat types. So to get us started, there we go. To get us started, funny enough, we're going to start above the waterline, which is one of our wetlands. Wetlands are prevalent in the Tamar Estuary, and they are an important habitat type, particularly as they provide habitat for many diverse plants and animals. And they also help us manage our environment. They're really good at filtering out pollutants and capturing sediments and any heavy metals that are bound up with those sediments. So as you can see in the image here, we've got the emergent plants, the Phragmites, and you've got the water there is just covering the mud flats. And we should all, those of us that live on the Tamar would be familiar with those mud flats that are exposed each low tide. What I wanted to show you was some of the I've done it again, sorry. Some of the plants and animals that utilise these habitat types. First, we've got the birds there. Now, if you're going to a wetland in the estuary, say Tamar Island wetland, you would be there primarily to see the beautiful birds that utilise that habitat. Whether they be like the mother bullcoot here with her fledgling, or it's the wading birds or the predatory birds flying overhead, they all rely on that habitat for shelter and food. But there's all these other animals. Who would have thought that you'd get macropods like the paddymellons and the water rats and antechinus living in and amongst the wetlands? There must be enough dry land in amongst it and enough food for those species to be able to live there. And then you've got threatened species like the green and gold bell frog. They're quite prevalent in our wetlands. However, they do need the high quality water that wetlands produces. So we really need to look after the wetlands to make sure that some of these other species aren't lost because of the way we manage them. And then also wetlands are very important for fishes. Tasmania's got quite a number of native fishes that use these wetlands, whether they be freshwater or saltwater brackish water species. But the one I've got here is not a native species. This is the Gambusia or plague minnow, which was unfortunately introduced in the late 90s. And I've decided to put it in this exhibition because it shows just how bad things can go when we make poor ecological decisions. This has a common name of the mosquito fish because they thought in the past that it was good at eating mosquito larvae, and nobody likes mosquitoes. But it's no better at eating mosquito larvae than our native species. Yet because of the name, it's been spread around the world. And since arriving here in Tasmania, eradication has been impossible. It's been successful in closed waterways like dams, but in the wetlands, you just cannot get rid of them now. Each year they bloom up into huge numbers. That is a female. She is carrying probably 50 to 100 live young. As soon as they emerge, they will begin feeding on plankton and they'll quickly grow. She may produce 5 or 10 broods in that year. So the numbers really grow quickly. They outcompete all of our native species. They also fin-nip tadpoles like of the green and gold bell frogs, so that can damage their populations. And they also hurt our native fishes as well. So wetlands, they're great, but we need to do a better job at managing them. Also, what you can't see here is the mudflat. In Launceston, we don't seem to like our mudflats, yet you go down the river, the estuary a little bit further. We don't talk about rivers when we talk about the Tamar. Mudflats are celebrated. Here, the water has just come in on the tide, and with it, all of the fishes have come in to feed on those soft sediment banks, and then you've got the wading birds that come in to feed. So those mud banks, they're critical habitat for a range of species, and we need to learn to appreciate them better and the animals that live on them. So let's go underwater. This is a typical scene of soft sediments down towards Batman Bridge. Now, you would have seen in the video the orange-brown colour was the soft sediments, and they extended for 60%, or 2/3 of the estuary. Here, this image is in 16 metres. The first thing you notice is how much soft sediment material has been resuspended when I dropped into that location. Just the bubbles from breathing were enough to create convection currents and resuspend all that sediment. And you can see across that the substrate, there's that fine coat of soft sediments. Below that, you can just see some granular sand and shell, and then we can get to what lives in and on it. In the lower right corner, you can see some of the maroon colours, which are a basic algae. And then, of course, the thing in the middle is some type of animal. I don't know what type of animal. It could be a sponge, but might not be. It could be an ascidian, might not be. Problem I have is the sediments made it impossible to find that animal and bring back to the museum to discover what it is. But what it does show that these soft sediments have animals that live in the sediments, which we call infauna, and you also have animals and plants that live on the sediments, epiflora, flora and epifauna. So the other point being, these mud banks and sediment beds, they're not dead. They're living, thriving habitats in their own right. Just a little bit further downstream towards Beauty Point, in some other soft sediments, you get different animals. And the flounder in the top is sitting on coarser grain sand, and it shows the mounding, the hump and hollow of where animals have been living in the sediment and moving around, or other larger predators have been coming through and sifting the sand to find food. There's also a little bit of brown algae on the sand, but it's more likely to have been passing through on a current where it's been broken off from a rocky reef. This is one of the problems with soft sediments. Some animals that need a hard surface to hold on to, they simply can't live in these mobile substrates. And that's why I put the crab in this image. This, battle-scarred crab, he's missing a claw and he's missing at least one other leg. He would normally have an orangey coloured shell. For scale, he's probably the size of a softball with legs. So he's not a small crab. He's not orange on the back though. He's covered in fine film of all types of plants and animals growing there. For instance, on his nose is a sponge growing. These animals are floating around in the estuary as a larval soup, looking for somewhere to settle out. And in this case, these animals have unwittingly landed on the back of a crab. It helps the crab in terms of camouflage, perhaps, but won't survive in the long term because that crab will shed his shell and have a nice sparkly new orange shell. So when it comes to certain animals, they need the hard rocky reefs, and we're going to go to that shortly. The bottom image is of a tube anemone. Now, this is a pretty unique and cool animal. It previously was only known from Bathurst Harbour in southwest Tasmania. This photo was taken at Kelso near the Heads, and yes, it's living in the soft sediments, but it's a tube anemone. Its tube is about 30 centimetres long, so I had to dig down to see what it was held on to, and it was fastened to a rock. So this is a slightly different habitat type. This is where two habitats or substrates are meeting, and it allows different animals to live there. The next habitat living on soft sediments is our seagrass beds. Now, these are a critical habitat worldwide. If you can join us tomorrow at 10 o'clock with Dr. Chris Mabin from the University of Tasmania, we'll be talking more about how marine plants help capture carbon for bringing carbon back into the ecological system rather than it being out in the atmosphere. But back onto this one. We've got about 5 species of seagrass here in Tasmania, and each of them has a slightly different niche. This one in the top is called Amphibolus. It forms quite a dense mat. There'll be lots of different invertebrates living amongst it. You can see a fish in the back left corner. It also allows some algae to get a foothold. And so here you can see some brown algae mixed in with it. This is growing in the top couple of metres of water. The bottom left image is Holophila, and it's growing in deeper water around 14 metres. And you can see there that although it's in soft sediments, it's also surrounded by brown algae. So it's in a bit more of a mixed setting. And then the middle image is Posidonia. This again grows in the shallower waters, but in this case, it's growing so shallow that at a low tide, neap tide, it's exposed for a short period of time to the atmosphere. And then the bottom right image, we're back to Amphibolus again, and I just want to make the point here that, like the crab, the plant also supports a lot of different life. The leaves on this plant are encrusted with other plants and animals, and that eventually reduces the ability for that plant to photosynthesize, or that leaf. And so what the parent plant does is we redraw the nutrients from the leaves and shed those leaves. That carbon-based matter then gets either sequestered into the soft sediments around it, or in some cases, particularly Tasmanians be familiar with seaweed or seagrass rack on the high tide mark at the beaches. So seagrass beds are a very important habitat here in the Tamar. Then we can finally talk about the rocky reefs. This is probably where most of the diversity in the Tamar is. There's 3 images there. The bottom right image shows a very complex algal bed where brown, green and red algae are competing for a foothold on the reef, and that dense mat is a great habitat for a range of invertebrates and fishes. Above it is a different type of algal growth, and that is the giant kelp, Macrocystus. This forms a 3-dimensional forest type canopy, similar to a land-based forest. In this case, it's rooted onto a rock in about 7 metres, and it's growing up 7 metres to the water surface and then laying over the water as well. This is one of the fastest growing plants in the world. It's also a critical habitat for a range of animals. Things like some of the small shells that are used in indigenous shell necklace making would normally live on this plant. When they die, they get washed up onto the foreshore. Unfortunately, over the last 50 years, the amount of Macrocystus in Tasmania has dropped dramatically. We're down to just a percentage of what was there in the past. This may be related to climate change, where the East Australian current is pushing down further and stronger each year and bringing with it less nutrients. The final image there is a rocky reef just a little bit deeper in about 17 metres. So in the Tamar, light penetrates down to about 17 metres and supports photosynthesis, whereas beyond 17 metres, there's no plants, and so you get only marine invertebrates growing. So in that image, the only plants that you can see are maroon algae. They are probably the hardiest plant in the estuary. They grow down to that 17 metre mark. But in amongst it, you can see a whole bunch of different invertebrates. There's anemones in the foreground, and there's sponges in the background. And on the next slide here, I'll show you some even more complex habitats. And there's gaps in amongst the rocks. And in there, we get giant cuttlefish laying eggs, and the males stay with the eggs to protect them. So there's a giant cuttlefish just poking his head out to ward me off from the eggs. The eggs are hanging down from the ceiling. He's just making sure no predators can get there. On the top right, you've got quite a complex marine invertebrate assemblage. In the foreground is a red, orange-coloured soft coral, Zimmer's fan coral, and pretty much everything in the background of that image is an animal, whether it be the vertebrate fishes swimming through amongst it or the invertebrates in the background. In the bottom left, I've zoomed in on a bit of that complex habitat, and pretty much everything you see there is some form of animal. Bryozoans, soft corals, ascidians, there's tube worms. So it's the exhibition that you'll come and see has cherry-picked that kind of habitat for the hero images that have been hung. And then, of course, you've got a lot of vertebrate animals that live in and amongst the invertebrate assemblages. And here, iconic of the Tamar is this big-bellied seahorse. In other parts of Tasmania, there's concerns about the health of the populations. They're concerned that there's only one male for every 5 females. The problem being there that it's the males that carry the young rather than the females, and that some of the water quality issues in those waterways have degraded so badly that the seahorses can't live there. That's not the case here in the Tamar. The Tamar is quite healthy, and seahorses can live from in amongst the seagrass beds right down into the deep channel in amongst those invertebrate assemblages. And finally, I just wanted to show you another beautiful animal, one of the animals that features highly in the exhibition, which is the sea star. The Tamar is just so full of sea stars. The variety is amazing and the biology and ecology is amazing. So I have put a lot of effort into reflecting those. And in the background is another important part of the Tamar estuary's ecology, and that is the green algae Caulerpa. This grows quite dense beds across the rocks. So here we're seeing 2 animals competing for the one resource. It's likely that the sea star is feeding on that plant there. So there you go. What I've tried to do here is give you a bit of the background as to what made it into the exhibition. Although the images are about the individual animals, they represent some type of habitat type and some of the factors that determine where a habitat type may be. So with that, we're probably a little bit short there, but I'm going to see if we've got any questions. Excuse me for one moment. So, okay, so we've got here, we've got somebody again from the US signing in saying she's enjoying the presentation. We've got one question here already from Heather, who's asked about diving in the Tamar and the conditions. And that's a good question because the Tamar estuary is one of the most difficult places to dive. The currents are very strong. Each day, the tide comes in 3 metres in depth. That's around 300 million cubic metres of water rushing in and out. And so what we end up with are these strong turbulent currents. We've also got low visibility because of it's a highly productive system. That means that the nutrients are feeding plankton, which feeds the whole of the ecosystem below it. And the temperatures can be quite cold, and particularly in winter, it's around 9 degrees. And the salinity right down to the heads can be very low, nowhere near the full salinity. And the combination of these conditions can make it extremely hard for the diver, particularly when you've got 50 kilograms of gear, weight belt and all your gear and camera, to not only be able to get in, get out, swim around, find an animal, set up the cameras. So, yeah, it can be quite challenging. Most of the divers that use the Tamar understand when something called slack water will be. They know that in a particular location it may be 20 or 40 minutes after high tide, and that's the best time to dive because the currents aren't as strong. And with the incoming high tide, you've got better visibility, the turbidity is lower. And then, of course, there's quite a dive fraternity here that use boats to get to some of those more inaccessible locations. If somebody was looking to take up diving in the Tamar, you wouldn't want to be a novice. You would want to have some experience, and you would want to probably go with a commercial company that knows the waterway and how the conditions are, and make sure you've got your buddy with you. All right. Okay. We'll see if there's any other questions there. We've got one of the people here's made a great comment about, wow, so beautiful. I didn't realise there was anything in the Tamar but mud. Well, that's a really good point. So much of the community, particularly around the Launceston area, don't appreciate how much diversity is in the lower estuary. They're quite familiar with the Tamar Basin and what the perceived problems are with that Tamar Basin, i.e. they don't like the look of the mudflats. But in the lower reaches from around Beauty Point, Batman Bridge down through further, it's a highly diverse area. There are some biodiversity hotspots that are quite well known. We are getting people come from overseas now to look at those highly diverse spots like Fish Beacon. It's a great little dive spot. And it wasn't so long ago that QVMAG worked with the University of Tasmania to discover some new species of soft coral. So that alone expresses how little we know about the animals that live in the Tamar. We could have chosen any other group, but we chose soft corals because nobody really thinks of corals living in Tasmania. Most people think of corals being up in the tropics. We were able to work with a student to find 2 new genus and 4 new species of soft coral. And that's a pretty high hit rate considering she only collected 50 corals. So I wonder what else could be out there that we haven't discovered yet. All right. Doesn't look like we've got any more questions at the moment. If you're out there and you've got questions, now's the time. I will flag, though, that one of the problems with the Tamar, as I mentioned, around the Launceston area is that the local community don't understand it. And on Thursday, we're going to be lucky enough to be joined by Catherine Pugh, the City of Launceston's ecologist. Catherine's been studying the Tamar for about 5 years now and working with other stakeholders to better understand how we can manage the Tamar. And on Thursday at 10 o'clock, we'll talk through more about the physical characteristics of the estuary and more about the historic aspects of managing the estuary. This exhibition, though, is more about understanding the different plants and animals that are out there. All right. We've been asked just to flash up a couple of the photos that mustn't have made it on air at the start. So I'll put those up now. Thanks, Sarah. And while we're just flashing that up, Chris has asked if we have any hard corals here, as he found some small worm samples washed up on the beach. Well, Chris, no, we don't have hard corals in Tasmania. Our conditions simply do not let us grow hard corals, whereas trying to multitask. Our conditions in Tasmania only allow us to form these soft corals. And so the object you found was, well, it would be something else. It may have been a weather-worn cast of tube worms or such. I'd have to take that one on notice. I'd need to see your object. So here you go. For those that missed the first slides, as I said then, typical of what's in the exhibition, we're cherry picking that complex habitat to show you these hero photos, these iconic species. And just to reiterate, you've got your nudibranch up there. This particular species is extremely common in the Tamar, but when the water warms up, the diversity of nudibranchs is amazing. You've just got to get in there, sit at a sponge garden and wait for something to move. Imagine, as I said, that if your garden snails and your garden slugs look like that, you might put up with them. And there below it is your magpie perch. Beautiful. They are very charismatic. They always want to have their photo taken. And as I said there, you can see the dusty marks on his black stripe where the soft sediments have been ejected out his gills as he's been feeding. And there's the beautiful purple-tipped anemone. That's about the size of a tennis ball, that purple-tipped anemone. Now, one point I will make about what is in the exhibition is there's about 60 images on display, and they were mostly taken within a month. What I didn't want to do was go out and harvest images from across my, say, 10 years of diving in the estuary. I wanted to show how diverse the estuary is, and so it was a matter of putting in the dive time within 1 month to get the bulk of the images. It's a complex and very diverse and alive system. Now, just in case, there's your typical, just in case that one didn't flash up at the start for you, that is a typical wetland in Tasmania that we need to better appreciate, need to rehabilitate, restore those wetlands and learn to live with them, because they are so important to the health of our estuary. And of course, there's some of the wetland animals. I don't think I need to go back through all of the presentation there. I think some of those were up by now. Small eroded coral Chris, as I said, it's not a coral. I'll have to, I can try and find out what that is for you. It'd be great if you could send a photo into QVMAG inquiries. We might be able to give you an identification on that. All right. No, I'd love to see another question out there, guys. My producer's telling me I've got to keep going, but I've run out of content for this one, I'm afraid. So if it's all right, we'll end there. We do apologise for the technical issues at the start there, but that's what happens when you try going live. I hope you can join us tomorrow at 10 o'clock when Dr. Chris Maben from the university will join me to talk about the role of marine plants in tackling climate change. And again, on Thursday, if you're interested in the Tamar and more environmental topics, we'll be talking about the Tamar, an estuary, not a river. Hope to see you then. Thanks for joining us.